right, in this lesson we are going to review synthetic division, and then we are going to look how we can use synthetic division and apply it to the remainder theorem and the factor theorem. So let's start off by reviewing synthetic division. So yesterday you were introduced to the learning target. I can divide polynomials using synthetic division. So let's look at this example 2. This is page 37 in your note packet. So we're dividing the polynomial here, given here, by x minus 3. So to set it up, you're going to start by solving for x. So x minus 3 solves would be, you would just add 3 to both sides here. So x is 3. So our divisor is 3. And then we're going to use our dividend right here, and we're only going to use the coefficients and list them next to our divisor. So you want to check for standard form. Start with the highest exponent, so x to the third is our highest exponent, and so I'm going to write its coefficient, which is 2. After x to the third should come x squared. X squared, the coefficient there is -7. And then next would come x, which we're missing. We're missing our x term, so we're going to fill that in with a 0. And then lastly, our constant -4. So there's your setup. So now you're ready to perform your synthetic division. So you always start by bringing down the first number, and then you start your process of multiply, add, multiply, add, multiply, add, until you run out of numbers. So you're multiplying the divisor by this number you just brought down. So 3 times 2 is 6. And then now add those. -7 plus 6 is -1. And then you start your process over again. So divisor is 3 times -1 is -3. Now add 0 plus -3 is -3. 3 times -3 is -9. -4 plus -9 is -13. The number at the end is always your remainder. So, in conclusion, we can put our quotient together. So we go back to the beginning here, and our highest degree was x to the third. To give your answer, to give your quotient, you always go down 1 degree. So I'm going to start with the x squared, and then your x, and then your number there, and then your remainder. So final answer, 2x squared minus x minus 3 minus 13 over the divisor, x minus 3. Okay, pause the video, try the next one. So you set it up, x equals 1 here, so you're dividing by 1, and then 3, missing your x squared, so fill in a 0, and start your process. Bring down the 3, multiply, add, multiply, add, multiply, add, with the remainder at the end. And then go down 1, so start with the x squared, 3x squared plus 3x minus 2 plus 8 over x minus 1. All right, so that's a quick review of synthetic division. Now let's go ahead and turn the page. Let's go to page 38 here. And we're going to lay the foundation for the remainder theorem. So let's just do a little exploration, and then we'll put it all together and talk about the remainder theorem. So investigate. How is the value of P of A related to the polynomial being divided by this binomial. So you're looking at the same a term here. So for example, if you're given this problem, so here would be your dividend, and here is your divisor. So we're going to use synthetic division to divide this polynomial here by x minus 5. So x minus 5, you got to solve for x. So x equals negative 5 here. That's your divisor. Then we'll set up our problem here. So the highest exponent is x to the third, coefficient of 1, x squared, x constant. Okay, so let's go ahead and use synthetic division. Add, multiply, add, multiply, add. Remember, the last number is your remainder. The remainder is 4. So they want us to relate what happens if you take P of A. So our A is negative 5. So what if you do negative 5 and you plug it in for each of these x? What happens? Well, let's find it. So let's find P of negative 5. So I'm going to plug in negative 5 for each x here. Okay, negative 5 to the third is negative 125. And then this would be 25 times 10, 250. 29 times negative 5 plus 24. Throw that in the calculator, and guess what? You get 4. So the remainder is also what you get when you evaluate it at that divisor. Isn't that cool? Okay. Let's try it. Let's try another one. Go ahead, pause the video and try this. So this time, they actually give you the value. The value of x is negative 2, so you don't need to flop the sign. So this was once x plus 2. That's where that negative 2 came from. So when they give you exactly what x is, just use it. Then set up your problem. Okay, pause the video, try it. All right, what does that look like? So you bring down the 1, multiply, add, multiply, add, multiply, add. So what should happen is if I plug in negative 2 in for all these x's, my answer should be 5. Let's test it out. And just simplify here, and guess what? You get 5. And this works every time. So the pattern of this working every time helps us come to our theorem. And the theorem is called the remainder theorem. So go ahead and turn the page here, go to page 39, and let's look at this remainder theorem. So the remainder theorem states that if a polynomial is divided by the divisor here, the remainder is whatever P of A is. So you take this A term, plug it in for x into the bigger polynomial, and your remainder is the same thing as if you evaluate by plugging in that number for x. All right? So one more thing. This is also very important right here. If you get a P of A of 0, or if your remainder is 0, then you can say that the divisor is a factor of that polynomial. And that's important for what we're going to be doing later on in the chapter. That is called the factor theorem down here. Factor theorem states that your divisor is a factor of the polynomial if and only if you get a zero remainder, okay? All right, let's look at an example here. We're gonna go to page 40. Skip down to example 5 on page 40. Let's practice this. So we're gonna test to see if x minus a is a factor of p of x. So here's our p of x, and then your binomial is x minus 6. So in order for x minus 6 to be a factor of this polynomial here, we have to get a remainder of 0. So let's test it out. So here x equals 6. So we're going to use 6 for our synthetic division. Set it up. Multiply, add, multiply, add, multiply, add, multiply, add. Remainder is 0. So that means that x minus 6 is a factor of this polynomial here. So yes, x minus 6 is a factor. So that's using synthetic division, but our remainder theorem says that we can also plug in 6 for x. And if we get 0 by plugging in 6 for x, that tells us that this is a factor. So let's try that method. So this was method 1. Let's look at method 2 here. I'm going to use that remainder theorem. So we're going to plug in p of 6. So plug in 6 for x here. And then simplify that down. If you want to try this out yourself, go ahead, pause the video, and you can use your calculator to do all these figures. But just to save time, if you throw that in your calculator, guess what you get? 0. So by getting a 0 at the evaluation of 6 here, that tells us that, yes, x minus 6 is a factor. So 2 methods here. Whichever one you prefer, you can use. I prefer synthetic division. To me, that just goes faster. But it's up to you. All right, so let's build on that even more. And we'll use this to factor the whole thing out. So let's go on to page 40. Page 40. So down here, we're going to get into factoring it completely, but let's just practice what we just did. So go ahead and pause the video and see if, I want you to test to see if x plus 3, see if x plus 3 is a factor of this polynomial here. So 2 methods, you could either use synthetic division or you can plug it in for x. But in order for it to be a factor, you have to get that 0 remainder or an evaluation of 0. So go ahead and try that. All right, so you would start by, to check your work here, you'd start by saying that x is -3. So -3, if you're using the synthetic division method, you would divide by -3. Missing your x to the 4th there, so fill in a 0. multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. So this remainder of 21 tells me that x plus 3 is not a factor. Because you didn't get a 0 remainder, we know that x plus 3 is not a factor of this polynomial there. And then, of course, if you like the other method, you could do that. So then that would look like this, p of -3, and then you would just plug in -3 for all the x's in the problem. So this would be your setup there. And then evaluate that, and you would, of course, get -21. We know that because of the remainder theorem. So two methods, method 1, method 2, but both methods give us that -21 remainder, so we know it is not a factor. So let's move on. Now we're going to put all this information together, and we're going to factor out this problem. So our first one, let's look at A first. It says use the remainder and the factor theorems to determine whether the given binomial is a factor. And then we're going to take it one step further and give the factored form. And give the factored form. And we'll talk about that after we go ahead and divide it out. All right, let's look at A here. So x minus 4 is what we're testing. Is x minus 4 a factor of this polynomial here? So you got to solve for x. So x would be +4. And then fill in your numbers here for synthetic division. Okay, go ahead and use your synthetic division. So, you got a 0 remainder, so that tells us that yes, x minus 4 is a factor. Now remember, this times this would give us this. So I can say x minus 4 times, remember to fill in your x's, you go down 1. And you can say x minus 4 times x to the third minus 6x plus 4. And this is called factored form. Okay. Try it with this one. So first you need to test if it's a factor. And if it is, you would fill in your x's and write divisor times the quotient here, and that's called factored form. All right, so first you need to test it. This would be -5 here. All right, so that 5, that remainder of 5 tells me that x plus 5 is not a factor. So I can't give factored form for this one. All right, hopefully that was helpful in reviewing synthetic division and then a couple applications of that synthetic division, the remainder theorem and the factor theorem. All right, you are completed for your notes and you're ready to do your assignment.